Record. Okay, perfect. Okay, everybody, week 3. So there are several things that I have been kind of like gradually exposing all of you to as we move through the different weeks. Um, and there are things that are like Git, the Git process, and things like this that I was doing first as a priority because I want to make sure all of you are exposed to these different concepts, how to be very intentional about engaging with our AI assistants. Today I wanted to show you my setup, the way I actually develop these things. Um, and so I sent you this, like it was sorry, we together we sent you this guide to install things locally. And I want to show you a little bit why I prefer that over the Colab. Now, Colab has the advantage that it has the computational resource. So, at some point when we will need better, like we will need GPUs and things, that's going to be our go-to resource. But a lot of what we're doing these first weeks can be done in any laptop, basically. And so if you want to see a little bit of how I do this, and some of the benefits of doing this. That's what I wanted to start with. So the tooling that I ask you to install, the tool is called Visual Studio Code, and I'm going to. Oh, okay, Max. That I didn't know that. So Max just put in chat that we can connect with Colab using VS Code. So I will test that. I was not aware of this. It's been a while since I've worked with Colab. But if that is true, I would strongly encourage everybody to work that using that. So don't worry about that right now. I'll figure it out next week. Send you a guide. But thank you so much for the information. Okay, so Max, can you do me a favor, Max? Can you put that link in Discord because so that people have access to that? Um, so perfect. Now I'm going to start sharing my screen right now, so I'm not going to be able to see the chat. So Claudia and Phoebe, can you please keep an eye on chat because I'm not going to, as soon as I start sharing, I will not see messages anymore. So, okay, so what I'm showing you here is Visual Studio Code. And Visual Studio Code, if you're not familiar with it, and let me just remove these things because this is going to be in the way of recording. So Visual Studio Code is what is called an ODE. You may be familiar with it, but I don't want to assume anything about this. So ODE stands for, oh, I forgot what it stands for. Development Environment. Something development environment. And it allows you to see your project in many different ways and has like a lot of functionality that is beneficial. So in this moment, I'm looking at our repository in my Visual Studio Code. And this has here the Explorer. But there is also something really cool is that it has a full integration with Git. So actually, the overwhelming majority of all my Git work I do through VS Code. In fact, I forgot to push this week's branch. So I'm going to do it right now. But I'm going to make a small modification. Let me see. You can like clear this. I'm going to put a space here. I'm going to save this. And then one of the things that it allows you to do too is look at differences. So, oh, okay, I need to make that change. So if you run in Colab, and Russell help us diagnose this, you have to use this repo path. But if you run locally, you have to use this repo path. So when you look at this part of the interface, which is all the versioning, version control, and Git, Then you can see which files are new, they don't exist in the repository. These are files that I'm not meaning to commit anytime. But it also allows you to see differences between these, between what was there before your change. So this compares to your last commit, and it's really cool to see how things are changing as you do this. Now, this allows you to make commits. So for example, to do a commit here, what you do is it shows you the changes, then you stage the change. You have to stage your change and you put your message. This is the you're saving your game save name. So I will just put add space to OS, import OS line. This is kind of like a skill, actually. Your commits should be very explicit. Because this is kind of like what, if you ever want to go back and load the previous save, you want to be able to find which one is the one that you want to load. And not only that, but the commit history also gives you a sense of what you did and when. So, and then you can publish the branch, and that will make it appear in the repository. So that is kind of like this. This is a lot about the actual tree. So these are the branches, the main branches here in orange, with merge requests here. And I think I saw a message. Oh, okay. So, and it shows you how I branch from the branch, merge to the branch, go back to this, etc., etc. So it gives you like a visual insight into, and you can see here all the different commits, and you can do kind of cool things, like you can compare with remote, for example, and that will create like a difference that you can visualize. Let me see if I can do compare with merge base. Oh, there are no changes. Okay. Then let me compare with origin feature 3. Okay, in this moment I'm not finding, for this particular project, I'm not finding something where is a nice comparison. Let me see if I have another project. This is a completely different project, but I want to show you this. It has a more complex kind of like mixtures of branches. And I think I can compare with merge base. And now you can start seeing some of the changes here. So there is an entire new file, and that's what this looks like. And there are some modifications to the old file. So red is what I removed, green is what I added. So there was a typo in documentation here. I was missing an arsan cosine, so I added it. But there are like also changes here where I was changing a gradient, how I'm calculating gradients and tensors. So you can see these are kinds of things that are cool that you can do with VS Code. And you have your branches. So at this moment I am in the branch that is here, feature week 3. And I need to pull it into the main, which I will do during the break. You don't need to worry about that right now. But you can switch branches, you can create a new branch, etc., etc. So here are my feature branches, week 2 and week 1. And I have my feature branch week 3 here that I'm right now have checked out. And you can see what are the different commits here. I added a space. This is the last one. I added a space to the OS, but I fix a name with the notebook and initialize week 3, etc., etc. So those are all things you can do graphically with VS Code, which to me, I mean, the classical Git is a terminal-based interaction. And there are some people that are absolute wizards at this. To me, it's one of the most confusing things I have ever encountered. Like I really struggle wrapping my head around Git commands. And so having a way of doing this by clicking buttons really helps me. So this is an option for you. Another thing that is super, super cool is debugging. So if you're debugging script, I'll show you later when we debug script. In the notebook, you can debug specific cells. So you run things in a similar way with this or with an enter. This is going to create an error working locally, but it's okay. And then, oh, it didn't. Okay, fine, no problem. But here is where we load the Sunspot group catalog. Whether you're working on notebooks or you're working on script, you can stop the execution. So when I click on debug cell, this cell will run and stop in this line. You see that it became yellow. And you have access to the debug console here at the bottom, where you can actually both see and operate with variables. So now I can look at the data path, and it prints this. And I can look at the df, which is the table. And I could look at the df.columns, and it shows me the columns of the data. And when you run a cell that is going to crash, so for example, I'm going to say df equal to a. So I disconnect here, and this is something that is going to crash. When I debug this cell, it will stop just before the crash. No, it didn't stop just before the crash. When you are running this on script, it will stop before the crash. It seems that it doesn't stop at the cells before the crash in the cell. But so that's one of the things that is cool. And I will give you a better tutorial on debugging, because it's very powerful once you're doing script. So the debugger is also really cool. There is also the remote explorer. And this repo, I'm running all this in my machine, not in my laptop, but in a machine that is at my work. It's called Beastie. And this allows you to interact and connect with a bunch of different things, like including Google Cloud, and potentially the interaction with Colab will be that way. But it also allows you to connect with WSL targets. So when you are developing in a Windows machine, let me create a new window. Sorry, not a new. So when you are developing in a Windows environment, you get the best of both worlds. So most of the packages for deep learning and have support if you use them in Linux, but they don't have support if you use them in Windows, Linux or Mac OS. And so part of the guide was to install Linux, the Windows Linux system, so that you can potentially connect to one of these things. So, for example, here we'll open into a repository that is the Surya Foundation model. And so, it connects to this, it has the system, it has the branches, and all this is in the Linux installation inside my Windows. But now you get access to all these things. So that's the other thing that is cool. And then you have this extension, the extensions. There are a ton of extensions for VS Code. I gave you kind of like my recommended ones, but there are extensions for everything, including Gemini. So you can run Gemini directly natively in VS Code. Live share is kind of like Google Docs in VS Code. So if I share a session with you, you could join me, and maybe I will do an exercise on that actually. And you can co-work in someone's machine and co-develop in someone's machine the same way as you can write at the same time in a Google Doc. Now I have the Cloud Codes extension, so the same one as with the Gemini extension. This Cloud Code is directly connected and cognizant of your entire set of files that you have in this folder structure. So these both Gemini and Cloud Code and other extensions that enable this will allow you to have the agent modify your code directly. So if you find yourself sometimes copying and pasting answers with the AI and so on, the VS Code will um, help you like deal with that. So it's the last thing is context. There is this once you have the Python extensions, then the thing is going to give color context to everything that you're doing. This is true for Colab as well, but you can see where a function is defined and go to where it's used and jump in and out in different parts of your repository. Now, for maybe show you as we start developing reusable infrastructure, or I start developing reusable infrastructure for you, I will give you a better template on that. So anyway, I wanted to expose you a little bit about this tool and recommend that you learn to use it. There are forks from VS Code is open source, and there are closed like commercial forks from VS Code like Cursor, which are are a product in and on themselves. So you pay for that and you have access to like a full integration with an AI assistant, etc., through the Cursor ecosystem and things like this. But it's a very, very, very common because it's so widely used. Then there is a lot you can do with it. So okay. So I don't know if you guys have any question about VS Code, but I wanted to show you a little bit of how it works. I love it, by the way. It's part of one of the things that makes satisfying to code to me. Um, so debugging, all that stuff, like you feel like you have a lot of control and a lot of support, and so I recommend very much that you find an IDE. No, ODE. ODE is ordinary differential equation. IDE, integrated development environment. That is what it is. So I recommend that you find your own. There is PyCharm. PyCharm is paid, but as a student you get it for free. Um, and because it is a paid product, it has a better user experience in some aspects compared to VS Code. So if that's what you want to use, by all means, PyCharms is an incredible product, and they're very generous with students. So even in the academic setting, so you cannot go wrong with PyCharm. Um, you cannot go wrong with VS Code, I think. So as long as you have a good IDE, okay, yeah. Ainsley uses PyCharm, and PyCharm interacts with AI assistants, and you can do all these things as well. So check it out. Um, okay, so now I want us to go back to the to concepts, okay? Because we have a lot of our participants potentially in spring break this week, and they are going to be looking at this offline. I'm going to delay an activity that I wanted to do with all of you about networking. So today we're going to focus on concepts. And now that I remember about this, before I forget, and Claudia or Phoebe, if you can do me the favor and put this in Discord with an announcement to everybody. Next week, I plan to do kind of like an introduction to the solar cycle with rubber bands and silly putty. So if you could get yourself a pellet of silly putty and a rubber band, at the very least a rubber band, you will be able to truly enjoy the experience. Okay? So anyway, we'll also send a reminder next week for you to get yourself one. So, but today I want to focus on concepts because these weeks assignment, and the one that I'm going to give you today are like chock full of concepts. Like there is a very strong possibility that you will not understand every third word of what I put there. Um, Maybe or maybe not, but there is statistical concepts, there are like curve fitting concepts, and you already encountered a lot of these concepts last week. Now, your AI assistant is super helpful, but it can be a crutch. So, with the idea of all of us becoming equal partners, and like the the idea that in order to become equal partners, we need to learn how to speak about things. I want to hammer that today and on that concept on all of you. Don't gloss over the fact that you have an AI that can explain things could potentially create a situation where you gloss over concepts because the AI just summarizes or like translates it into a more day-to-day language. But I would like to actually do it the other way. Elevate your vocabulary. Elevate the way you can express, and the concepts that you work with when you do data science analysis. Okay? That I believe, and I've told you this, and I'll tell you this every day, every class, every Friday. That's what's going to separate you from other AI users you're going to be competing with in the job market, in the development of products, and in science, right? That there are many users that will let fall into the temptation of the AI becoming a crutch. And so that's what I want to do today. So let's go to the Miro board again. And we're going to do it like last time. We're going to do it together. So join the Miro board. And I'm going to share my screen for those that are maybe watching this offline. And I want to do kind of like a capture of challenging concepts. So I'm going to give you, um, let's see. I want to give you a couple of minutes to look at last week's notebook. So ideally it will be yours, but if you didn't get a chance to follow through. But by the way, remember we're going to be keeping track of who commits in time, right? We're building right now the system to check and make sure that everything is like well done. I'll be showing you statistics next week. Um, and we'll also keep the statistics, basically help you plan, manage. How many have I missed? How many can I miss? Remember? But I want you to look at this and remind yourself which kind of concepts where uh, you know you don't understand completely still, okay? And I want you to capture them in the Miro board. I didn't put this in chat, but oh yes, I did. Yes, perfect. So you can open that notebook and look, at some of the cells, especially the task description. Um, and there are like for me it's hard to imagine now which ones may or may not be. But the idea of the drift, what does this mean in this context? Or what is a kernel? in the kernel density estimate. What does the kernel mean? Or density estimates. So these are like concepts, medians, quartiles, histograms. Some of them are like here bolded in this particular um, notebook, but probability density function, normalization, these are things that are mathematical concepts that are commonplace when you do data science. You may have not encountered it yet in your journey because you haven't yet had a chance, but I want to start capturing that. So 2 minutes for you to start to remind yourself which one of these concepts you don't fully grasp yet. You can use the 2 minutes just to look. Um, you can start putting things in the board, and I want to capture them in this gray area that I'm going to bring everybody to. So forgive me if I kind of like disrupted your view of the thing. Um, Now I want to focus on concepts you don't understand clearly. If there is a concept that you feel that you now mastered, that's not something that I want for this exercise, okay? And this also helps me to plan for next lecture and everything to see which things I need to focus on. Okay, this is not the space for that. We're going to submit a survey. I want you to focus on concepts you don't understand, okay? We're going to submit as like, but you guys are giving me space for this that I forgot to say. We're going to submit a survey at the end of next week that will capture some of these things, which are like the challenge that you're facing is time management. That survey will be the place to put this. Um, okay, so I'm going to erase those challenges right now from this board because that's not what I want right now here. Okay, I want concepts that were on that notebook yet you don't fully understand. Git committing is a perfect example. Git merge push pull. But that's what I want to capture right now. We will submit a survey for challenges and things like that. Okay? So now let me give you 3 times for you to capture those concepts. Capture as many of them as you can. Okay, be specific. I want you to be specific. Choose one of the terms that you are not understanding. Pick one. Hmm. Put another. If you have more, put it on another sticky note. I want you to dig deeper. It's surprised. I was not expecting to see so few. I'm going to add one more minute, and I will wait. Okay, so this is the this hints as one of the things that I think is critical when you're working with AI. Um, and I want this experience to kind of like act as a template, right? There are words, maybe you can kind of like develop a habit to always finding one thing in the answer that you ask for clarification for, right? There is a lot of, we kind of like, we are very used to understanding the gist of text and say, okay, that's good enough for me. I kind of get it. Um, and so, and if you couple that with an assistant that gives you the code that does exactly the task, you're set, right? Like you generally get the gist. You have an assistant that makes the thing. It looks okay. It looks like it works. Good. You're done. That is exactly the kind of mindset that I would like to transform or avoid in all of us, right? Always, if you at least find one concept to for clarification every time, you get into a mindset of not just being satisfied with vaguely understanding what the machine is giving you. And that is, I think, a condition for you to become someone that can actually innovate with AI, with the help of AI. And not a very passive user that basically is the human that writes down the task that was assigned to the AI. The AI does everything. You become like a. I'm not saying that you guys are like that, but the worst case scenario will be a human whose only job is to type things for an AI system, right? It's like You don't understand exactly the task that you're giving. You're not understanding the answer that the AI is giving you. And but if the AI becomes very, very good and your bosses are satisfied with the output that AI is providing, then all you do really is just become like a buffer between a human that is telling you what is necessary to do and a machine that is doing it. And that's it. Like you don't have a way of knowing whether it's doing something good. You don't have a way of adding value to the whole thing. Maybe you cannot really have ideas about how to do the task even better or more interesting or more. So that's what I want. So for next time, I want you to see if you can now don't let that pass. Let at least one concept. Don't let all the concepts pass. Just make sure there is one that you don't let pass. Okay. So now we're going to do the exercise that is together. Okay. So we're going to do it like last time. Um, which is we're going to pair you randomly with somebody. Um, and you're going to, okay, let me share my screen actually before. Um, Claudia, can you help me kind of like prepare the breakout rooms? We're 17, so minus the three of us, that's 14. So seven breakout rooms, random couples. And for the rest of you, let me just explain really quick. When you're paired, first thing I want you to do is that if you don't know each other, I want you to introduce to each other. So I will give you maybe a couple of minutes for one person, a couple of minutes for the other. Okay? And then I want you to talk about what you're seeing in these gray sticky notes. If both of like find one, at least find one that at least one of you doesn't understand. And if one of you understands it, you talk about it. And then go to your AI assistant, share your screen. One of you puts it in the AI assistant. And so, for example, this one, what is IQR? So you can copy it, Control C, paste it, Control V, and make a copy and put it here. And then get have like a conversation with your AI assistant about IQR, what it is, when is it used, what are the possible interpretations of this acronym, um, and do that for the rest of the exercise. And then when I call you back, or I'll let you know in a broadcast, put it back in the. So I want you to do a final prompt summary. Ask the AI to summarize after your conversation what IQR is, and you come and you paste it in these colored sticky notes. I put rows because it's possible that IQR is something that all of you don't understand. And so we will have 1, 2, 3, 4, 5, 6, as many summaries as necessary, right? But if there is more than one concept, not just IQR, but maybe Git committing, and you guys have an experience with your machine about what commit means and what is the difference with pushing, etc., and you put your summaries here, okay? I'm perfectly fine if everybody ends up picking the same concept or if we have different concepts. But what I want to really is build that muscle of having a conversation with an AI assistant around a concept, and I want you to do it together. Okay? Any questions about exactly how it's going to work? Okay. So we will open the breakout rooms, introduce yourselves, and you will be invited to join one of them. And we will join if we find any of you to be on your own. One of you us will join us. You and I forgot to say we are kind of like working with this assumption that everybody is bringing the best version of themselves to these breakout rooms. So I want you to encourage you to do this. It's kind of like we're all here because we want to be here. Let's treat each other with kindness and respect. If if ever it happens that you have an uncomfortable interaction inside one of those breakout rooms, you can reach out to me or Phoebe or Claudia privately in a message and let us know, and we will work through the the issue. Okay. Um, Claudia, are you able to open the rooms?
I am. I'll open them right now.
Okay, perfect. Okay, so William may be AFK. Um, so one of will one of you go?
I'm gonna move Lana to the room with Ethan, maybe.
Yeah, because there was one breakout room with three because of our numbers.
There we go.
Okay, perfect. And let's remove William.
Wait, why are you where what do you mean remove?
No, I mean, okay, sure. Room 2 has three people, but one of them is not joined. Um, and Hamza, you just joined, right?
How's it? How's it,
Uh,
Rayhan?
I sent you back. Okay, there we go.
Okay, perfect. Okay, perfect. I think we're good. We could potentially add a room just in case, but I think we're good. So let me do 2 minutes timer.
We have two Williams. William, are you
William, are you
there?
there?
My computer has been freaking out for like 10 minutes now. I cannot move on Zoom, so I joined from my phone real quick.
Okay, okay. Um, so what we can do is create a room and send you there with Phoebe.
Yeah, you can move me there. Claudia, that's that. Here, let me join room 7.
So I will send you to 7, and William, I'll send you with Phoebe, and you work together, okay?
Sounds good.
I am going to stop recording.
Fair.
Okay, perfect. If you take a minute to look at that board, I'm going to share my screen. You start seeing the goodness that is in AI, right? So let's look, for example, at IQR. I'm going to increase this size a little bit so we can see. So there is an explanation. It measures the spread of the central 50% of the dataset, specifically the distance between the 25th percentile and the 75th percentile. And there is an explanation of how it's calculated and a resistance to outliers. So why do we use it, etc., etc. You can see also the kernel density estimation. It's the sum of many small normal distributions for each data point. And there is a connection in this particular answer with the solar cycle. So these are kind of like, this is really where I feel AI is transformative, right? You have this assistant that has an incredible understanding, like, like conceptual abstraction of everything humans have done prior to 2025. It's insane. Like, it's super, super current. And a lot of them can even go online and do a Google search and parse through documents and give you summaries that are beyond the window, the horizon for which they were trained. And they are kind because they're trained to be so, and they are patient. And they can explain a concept to you for as long as you need until you get it. And that is where that is really the gold behind the potential transformation of AI in education. But it hinges completely on you as a student. You have to ask, you have to dig deeper, you have to be the driver of that elevation of knowledge. Because the machine doesn't, these machines, and maybe I think I'll give you in one of these weeks, I'll give you like an explanation of how these machines exactly work, these large language models. So that may help how you take advantage of them. But the whole point of the exercise yesterday is the last week was to expose you to the idea that in order to be called equal partners with the AI, we need to be able to express ourselves with great clarity and have an understanding of all the concepts that are relevant to talk about a problem. This week then builds on that. How do we make that a reality? We have to be, we cannot let the concepts pass us by. Because the machine gives you an answer and that's where everything ends. They are very proactive and may ask you a question. Do you want me to implement this for you? And then there is a very easy answer. Yes, please. Or yes, thank you. Right? But you can say, no, wait, before you implement it, I want to understand this. And so you have a conversation. And then it's like, but why are you, what do you, there are questions that actually unfold the problem. You say, no, before you implement it, I would like a plan. What are the steps that are necessary to make this happen? And so even if you don't have clarity on a task, just asking the machine to break it into pieces broadens the way you understand the task. And then if there is a concept, like there are 5 steps, you understand there are 5 steps and you understand the third step, then you can explore a little bit on that. So if you, let's say, kind of like develop the habit or always breaking things into pieces, finding one thing you don't understand and having at least 2 or 3 interactions around that concept, with time, you become a much more sophisticated user and a much more sophisticated human around the concepts that you're working with AI. And these exercises that you guys do together, where you work together around the AI, and these little snippets that I'm kind of like forcing you to do, forcing you to ask yourself, what is it that I didn't understand? You were not expecting me to ask you this question. Um, but now I want you to always ask yourself that question. What, what in this whole paragraph that this machine gave me is not very clear to me? Yes, I could close over 30% of the words and still get the gist of that paragraph, but that's not what I want you to do. Okay? So let's take a quick break, our 10-minute break, and then I'll talk about what I implemented for the solutions of last week's tasks, and we'll talk about the tasks moving for next week. I think today we probably will not take the 2 hours. Okay, so let's do a quick break. Okay, but before we do a quick break, I wanted to open the floor for a potential question around these concepts. You know, is any of you, like, we could talk about specific tips, like if there are things that you would like to know about how I interact with my assistant. You can ask me now, or you know, anything around these kind of like loops. I'll give you a couple of minutes and no, we go to break.
Have you had the issue of it recommending non-existent papers for you? And how do you catch that without just going and looking up every paper it cites?
So right now there is a bias that we all have. If that humans, maybe at some point we can talk about human cognitive bias. That when you feel like you understand something, the human mind gives that something a very strong sense weight of truth. And I suffer from that too. So many times I don't check. I, you know, I'm working with concepts that are more or less understand. The machine is giving me things that make sense to me. I explore the concepts and I kind of like use them to build the concept. You know, we all we all have a limited amount of time and resources that we can do to double check, as you're saying. And so it also depends on this on I will say it's a judgment call. You can always, if there is a, I think that when we're working with academic concepts like we're doing right now, my experience is that the machine is very accurate. So when you are, for the majority of you in the context of this program, when you engage with these concepts, the machine is really aggregating the wisdom of our scientific community around them. When you are, and in this moment, a lot of you are working in implementation. So that is a context in which I tend to trust the machine. And so I just focus on understanding what it's telling me. Now, when the machine has kind of like shown that it doesn't, it's not taking you exactly in the right direction, is when you're being truly innovative. So these machines are trained and they are in some sense a consolidation of our knowledge in the form of text. And that means that they are able, so there are two components to innovation. One is existing ideas in contexts that have never been applied. And in that, the machine really shines. That kind of innovation, the machine is an incredible partner. And so you can get a sense of, you know, does this technique is well established? Is it, have people used this in other contexts? And when the machine is telling you, yeah, this has been used in so many problems in so many aspects, you don't have to double check it. I guess that's kind of like my approach. I'm actually formalizing my understanding as we go. I feel like the machines really, you can trust them when they're like really working with well-established things. So kernel, the majority of these concepts that we're working with are very well established. Kernel density estimation, Git commits and pushes. You don't have to double check any of those things. But when you're working with a concept that has never been implemented or has never been implemented, or is kind of like deviates from the conventional wisdom, then you have to double check everything. It's really hard to assess that. But you can kind of like get a sense of it from how universal is the application of the concept. That will be my answer. But these machines can be trusted to a great extent. My premise actually is that we can trust them. The whole point, I will say, the biggest error we can commit, there is a bigger error in treating them like crutches. There is a bigger risk, and it is more detrimental to us to treat them as crutches than to trust them. When we treat them as crutch them, we are completely and blindly trusting them. But when we kind of like ask questions and use them to build our own understanding, I think we can, more like 99% of the time we can trust them. Okay, so let's take the quick break. 10 minutes, stand up, get a glass of water, and I'll see you in 10 minutes. And then we'll go briefly about some of the concepts that we saw and what are the concepts that we're going to be moving next week. So let me stop recording. Not recording. And share my screen. Okay, so as we're moving towards this process, I have kind of like shifted the burden of understanding a lot of these concepts to you and your AI assistant. Because I wanted to focus on the mechanics of interacting with your AI assistant and tooling and Git repositories and things like this. But as we move forward and those concepts start settling, I'm going to now focus more and more on what we're doing and why. So here in this notebook that you saw last week, and this is the extension of it for this week, we are dealing with the concept of the butterfly diagram. Okay, the fact that there are regions in the sun that appear, and over very long periods of time, decades, they increase and decrease, and they have systematic patterns in the way they appear. Close to the equator, close to the poles, there are two hemispheres. They're kind of mirroring. You have it's almost like a mirror across the equator. Not perfect, but there is a synchronicity between the two hemispheres, etc., etc. These regions are the origin of the majority of the space weather that we experience, or are connected to it in a very fundamental way. And so they are very important for us to understand when it comes to understand how the sun as a star works, how other stars work, and when we want to do long-term planning. Meaning planning something that has to do with space, something that is going to take place more than 1 month, more than 1 year, like putting a person in Mars. We call a solar cycle a realization of one of these butterflies. So one wing in the northern hemisphere, one wing in the southern hemisphere, this is a solar cycle. It starts somewhere in between because there is an overlap. You can see that there is an overlap here between cycles. When you're looking at the last regions of one cycle, the ones from the new one are appearing. Now, as I told you, the appearance of these are like hurricanes. They are not something we can predict a year ago ahead, right? So we have to talk about them in a statistical sense. And the more sophisticated that statistical description, the more we can do with it. And that's kind of like what we're trying to establish. So, okay, so this is the illustration of a single solar cycle, which is the two wings, not perfectly symmetric, but more or less in synchronicity. Okay. Now, when you're trying to describe the statistics of a system, you are conceptually talking about information compression. So you are talking about a reduced set that broadly allow you to describe the behavior of the system mathematically that is not the system itself. So it's always less information. When we're talking about distributions, the solar cycle is a two-dimensional, as we are interacting with it. This is our working definition of it. It's a two-dimensional process. We're going to engage with it as a two-dimensional process. Something that happens in time, something that happens in latitude. Okay? So we need to describe a structure, a statistical structure that is two-dimensional. There are places where there are regions, there are places where there aren't. There are places where they're more, there are places where they're less. There are places where they're concentrated, and there are places where they are sparse. And that's what we are aiming to capture in this program, both in a classical sense, which is where we started, and then using AI. Okay? Means and standard deviations, like the expected location of these regions and the spread of them around that expected region, means and standard deviations are kind of like where you typically start when you do statistical descriptions. These are the basic concepts around the statistical description, and they're very powerful. And they allow you to understand a lot about your system so that you can refine. And that's what the purpose of last week's exercises. So the first thing was talking about latitudinal paths. When you look at the mean location of objects as a function of time, you're starting to create the elements that allow you to make a statistical description of the solar cycle, and that's what we're going to be building on. So in that template that I gave you last week is also the same for a single solar cycle. So we start with what I asked you last time, the idea of the empirical distribution. So there is a distinction between what the data is telling you and how you are describing them. That how you are describing what the data is showing you. And that's the difference between empirical and analytical. So empirical is us trying to understand where things are, where they aren't, where they clumped, and where they're sparse. Okay? But the analytic is us summarizing where things are, where they aren't, where they clump, and where they sparse with a mathematical expression. So the first task was to look at the empirical distribution for a single year that looks something like this. So this is 1960 Northern Hemisphere. And you can see that in that particular year, things are kind of clumped around 10 to 20 degrees. But they span a range that goes between the equator and 35 degrees, right? So if we look at 1960 in our little diagram were kind of like here. So we could look at what happens in 62, right? Now, things are kind of like clumped differently. They are closer to the equator, clumped closer to the equator. Um, their span is kind of like less. It was used to be 35, now it's 225. We can also see what happens 2 years before 60, 58. And now there is like things spread further in latitude. So the spread goes all the way to 46, 5, and they're clumped differently. So this is what you're looking at here is a histogram. A histogram is the way we look at empirical distributions. We create artificial bins and we count how many data points fell into that bin. Now, the analytical distribution is a summary of that. So let's work with 62 because I just showed you 62. And I ask you, okay, there is a normal Gaussian distribution. The normal Gaussian distribution is one of the most common ways we have of describing almost any statistical system because it's very common in nature. So we see it a lot, and that's always the place where we typically start. It's a symmetric distribution around a mean that where things are concentrated in the center and they gradually decrease as you get away from that center. It's described by two parameters, the mean and the spread, mu and sigma, the mean and the standard deviation. And so here we're going to do 62, so I'm going to rerun this cell. Not 62, 58, that's what I wanted. It's a nicer one. So there is a process by which we can optimize the match between our observation, our empirical distribution, and the analytical description, which is using this method SciPy stats norm fit data. I really encourage you that you take some time to learn how this is fitted, but we can treat it as a function that gives us the answer. And basically, this is the best Gaussian that describes this data. Not a bad approximation, actually. But you can see where it breaks. This is actually non-symmetric. It's like heavier on this side of the mean. It's kind of like has a larger spread than on the equatorward side. But that is basically what we're telling you. But it allows you to now start talking about these wings in terms of a mean and a spread. Even though if it's not optimal, it's not a perfect approximation, it's an okay approximation, and it allows you to already to make useful and usable statements about where things are and where things aren't. And in fact, I don't know if you saw the Discord, but there was like, I cannot I don't know exactly how to pronounce the name. Ansley? Can you please correct me, Claudia? Anyway, Ainsley. One of you actually established a relationship between the mean and the standard deviation that heliophysicists had never established until I think about 7 years ago. So if you're curious, you can go and see. And that's something that I was planning to take you through maybe in 1 week or two. But that's the power of these things, where you can start describing the universe using math. Math also allows you to simplify a very complex data in ways that we humans can interact with. Now, the eighth thing is that this distribution changes over the course of the solar cycle, and I maybe will, as we go, we'll give you a quick, like one of the weeks I will talk about visualization. I'm pretty good when it comes to visualization. But we can do here, let's do 1960. This is cycle, let me remind myself. This is 5, 4, 3, 2, 1. 19, 18. Am I getting 5, 24, 23, 21? No, 20, 5, 4, 3, 2, 1, 0, 19. 19. So let's look at 19 north here really quick. Nineteen north. So this, what you're looking at here is that wing with the yearly distribution, an empirical distribution using that kernel density estimation. So kernel density estimation is another way of looking at this empirical distribution that has some advantages over histograms. So histogram is just I specify an arbitrary number of buckets and I count how many points in each bucket. This kernel density estimation is different. Is I take each point as a Gaussian and I add them all up. It's powerful because it's not subject to binning issues, like, you know, how do you define your buckets defines how it looks in the end. But you know what I wanted you guys to really see is the fact here that the distribution's properties change with time, both where the typical behavior is, where the mean, which is the typical behavior is, as well as the spread. Like there is a very difference in the spread in 59 that it is in 65 or 66, right? So that's kind of like what I wanted you to see here, that hints a little bit at what we are going to start to try to do. So the simplest distribution is the Gaussian, and the simplest way of looking at things is one-dimensional. So we can approximate a two-dimensional structure, which is the wing, as a sequence of Gaussians that they are connected all somehow in time and space. And once we establish a relationship with how the typical behavior evolves during a solar cycle and how the typical spread and the spread behaves over the solar cycle, we have taken the advantage of turning a one-dimensional distribution into a two-dimensional structure. That's kind of like the direction that we're going to go. So those are the tasks that I want you to focus on for this week. First, we need a way of talking about the solar cycle in a standard way. So here we have every single cycle separate. It's a different entity and we look at all of them. But to all of us, even to our untrained eye, you see that there is more that they have in common than that they have difference. The all wings, they all have migration. Their migration looks the same. You know, there is a symmetry between north and south, etc., etc. And we want to take advantage of those things. So the first thing that I'm going to ask you to do is to think about standardization. In this moment, our solar cycles exist in time. And they are different from each other because they take place at different times. I want you to now, the first exercise is going to be how to reframe every solar cycle so that they exist in common time. And now we can start describing them in a frame of reference, in a mindset where there is a standard time. And that standard time that the way I want you to experience this is through the time when the solar cycle crosses 15 degrees. It's an arbitrary number, and I can explain later the logic, but you can see that 15 degrees is somewhere around here in this wing. A good reason is every solar cycle crosses 15 degrees, no matter how weak or strong they are. Second, 15 degrees is a kind of like a well-represented part of the cycle. There is always quite a bit of objects. If you do earlier or later, some cycles are going to have too few spots or too few spots. So 15 is a pretty good place to standardize the cycle. So I'll ask you to do that. And then I want you to start looking at how different solar cycles compare to each other when you have them in a standard time that is referenced to 15 degrees. They will start overlapping with each other, and I want you to start using fits. Those pathways that the solar cycle follows, every solar cycle follows, can be approximated with a mathematical expression, and the one that I want you to use, because I know is the one that works, is an exponential decay. And so that is kind of like what this exercise is about. Fitting the path of a single hemispheric cycle to this, as given by your typical behavior, your means. And then the last thing is going to be looking at the spread. So we fit the centroid, now we look at the spread. What is the kind of behavior that we see on the spread? And the last thing is all solar cycles together. What happens when you overlay the path that different solar cycles follow? How do they compare? What do they look like? And what can we, this tells us, like what does this tell us about our ability to describe every single solar cycle in a similar way? Okay? So any questions about the concepts here or the tasks? So I will let you then interact with these concepts. Remember, this if if I if I thought last time I warned you that there was going to be a lot of concepts in the previous week, this is going to take that to the next level. And so don't let those concepts pass you by, okay? I am simplifying those concepts because I understand them very, very well. And I want you to, one of the things that I think is, that I love, and I think I would like you to gain is to connect the mathematical concept with the kind of like real life concept. That's why when I talk about means, I talk about typical behavior. When I talk about standard deviations, I talk about spread. And this is one of my favorite things about being a physicist, which is take what seems to be a huge amount of observations and elegantly and simply describe them with a mathematical expression. And that is kind of like what we're going to be doing in the next week. So I will let you all go now. Unless you want to stay and ask me a question, I'm happy to stay. Wish you a great weekend. Remind you that you can always schedule hours with us. Apologize in public for those that schedule hours with me and I failed to show up. But I understand now why, and promise that I will not do that next week. But, if there is something you don't understand or you want to chat about or anything, please schedule. Now, if you see something interesting, you can also schedule and we can talk about interesting things that you see. So, have a great weekend and see you next week.
Thanks.